Hi folks, welcome back. So we're looking at solving trig equations using special right triangles in this video. Call this 13.2 Part B if you'd like. So here are our two special right triangles. Recall 45, 45, 90 has side ratios of 1, 1, radical 2. And then our 30, 60, 90, the one across from the 30 is a 1, the one across from a 60 is a radical 3, hypotenuse is a 2. So you really just need to be aware of these numbers. So if you see 1s, if you see a radical 2 somewhere in a problem, if you see a 1 or a 2 or a radical 3, understand that those correlate to the sides in a special right triangle. Okay? So let's check out this example where we were looking to solve the equation sine of x equals negative 1/2 from negative 360 to positive 360. So in this question, we're not allowed to use a calculator, so we have to do it algebraically. Later on, we'll discuss how to do this if you were allowed to use a calculator, but that's a video down the road. So we're looking to figure out where the angle is such that its sine is equal to negative 1/2. Well, you need to recall that the sine of 30 is positive 1/2. Okay, that's hopefully one of the big three you have memorized. If you look at our diagram here, okay, the sine of 30, okay, opposite over the hypotenuse is 1 over 2. Okay, so 30 though is not an answer because notice this is a negative 1/2. So we call this 30 our reference angle. And from there, what we tend to do is we're going to put our 30 in here in the first quadrant. Our reference angles are always acute angles. All right, and so we also want to jot down the ASTC, which tells us where things are positive and negative. So sine is positive in the first two quadrants. Because this is a negative, we're looking for where sine is negative. So we want the answers in the third and fourth quadrant. So to get the third quadrant answer, you're simply going to do 180 plus your reference angle, so that would be 210. And in the fourth quadrant, you're always going to do 360 minus your reference angle, so that would be 330. Okay, so these are the answers that we have. These are the positive answers from 0 to 360. We have to back it up a cycle, though, because we see that it's going into negative territory. So to back it up a cycle, we're simply going to take each of these and we're going to subtract 360. Okay? If we needed to go forward a cycle, we would add 360. So when we do that, our final answers are these four angles. Again, put them in a solution set. We tend to list them from least to greatest, but it really doesn't make a difference as long as all four are there. Now, if you're wondering how am I supposed to do something like 210 minus 360 without a calculator, remember you can do 360 minus 210, just reverse your order, and then just negate your answer. Okay? So all that is no calculator. Let's go on to another example. Okay, in this example, we are looking to solve this cosine equation. We see a negative 1 over radical 2, and we're going from negative pi to positive pi this time. So really, that's negative 180 to positive 180. I suggest you think about it first in degrees, and then in the end, we'll convert it to radians. So this is not one of the big three that we said to have memorized. Remember, sine of 30 is a half, cosine of 60 is a half, tangent of 45 is 1. However, when you look at this, these numbers should hopefully lead you to the 45, 45, 90 special right triangle. So the 45, 45, 90 have side ratios of 1, 1, and radical 2. So let's think about what the reference angle would be. Cosine, so we're talking about adjacent over hypotenuse. So the adjacent side, if it's going to be 1 over radical 2, well, it would have to be 45, since the adjacent, if we look at this 45, the adjacent would be 1, hypotenuse, radical 2. So from there, what we do is we recognize that 45 is our reference angle. Okay, so this is our reference angle. So get in the habit of marking it in the first quadrant there. Then write out your ASTC. Once again, here we're dealing with a negative value. So we want to figure out where is cosine negative. Well, cosine is negative in the second and the third quadrants. So we need to find our answers by, in this quadrant, subtracting from 180. So that's going to give me 135. And in this quadrant, we're going to add 180 to the reference angle. So that's 225. Okay. Now, the 225 is outside of my range. However, don't forget, if we need to back it up a cycle here, we need to do 135 minus 360, and we also need to do this 225 minus 360. Okay, so we're looking at these answers so far. Now we know we're going to be rejecting this 225 because it's outside of our interval. Okay, but you still need to subtract 360 from it. Okay, so go ahead and do that. So we end up with negative 225 and negative 135. And again, when you subtract, just reverse the order to make it easier, and then just negate it. All right. So we can see that this negative 225 is outside of our interval. So our only answers here are positive 135 and negative 135. But we need to make sure we do it in radians. Okay. Remember that 135 is equal to, well, think about how many 45s go into it, right? That's 3 45s. So that means we have 3 pi over 4s. Remember, pi over 4, you should have memorized, is 45. Okay? So we have a negative 3 pi over 4 and a positive 3 pi over 4, since our answers were plus or minus 135. Okay, so this would be our final answer to the question. Okay, our next example here, we see a tangent squared, and it's equal to 3, and notice that 3 is not one of our side ratios in our special right triangle. So before we panic, understand that there's going to be something algebraically that you can do to make one of those numbers show up from these special right triangles that we saw on the previous page there. So think about what we're trying to do. We're trying to solve for x. So wouldn't it be helpful to get tangent of x by itself? Well, to get rid of this square, I can square root. So if I square root, I'm going to end up with plus or minus radical 3. And hey, radical 3 shows up in one of our special right triangles, right? So radical 3 shows up in a 30, 60, 90. Okay, so radical 3 is a side across from the 60. So if we're talking about the tangent, remember tangent is opposite over adjacent. So you could really think of this as being over 1. So opposite over adjacent. So where would you have to position yourself for the opposite over adjacent to be radical 3 over 1? Well, it'd have to be 60, right? This would be the opposite, this would be the adjacent. So we go to our diagram, our ASTC, okay? The reference angle would be 60. Now, because we needed this plus or minus from square rooting each side, what that really tells us is that we're going to have all 4 quadrants as our possible answers, okay? Because we're going to have the 2 where tangent is positive, which is here and here. And then we're going to have the 2 where it's negative. All right, so the plus or the minus means we're really in all 4. So in our second quadrant, we're doing 180 minus 60, so that's 120. Okay. In our third quadrant, we're doing 180 plus 60, so that's 240. And in our last quadrant, we're doing 360 minus 60, so that's 300. You don't have to show the 180 minus, the 180 plus, and the 360 minus. I'm sure you're capable of just doing that in your head. So from there, we're just going to list out our answers. Notice it says 0 to 360, so we don't need to change anything. So these would be our possible solutions to that equation. Okay, another equation we're looking to solve here. By the way, please go back to the previous example and write the word solve. I forgot to do that. So we're looking to solve another equation, this time from 0 to 2 pi. And it looks like we have a trinomial with signs in it. So this is more complex than what we saw before. But before you freak out, understand that if I were to give you something that looks very similar, such as this, you most likely would not freak out. However, maybe you would, since it's a tricky trinomial. Right, so recall that if this is a tricky trinomial, we're really doing add multiply game. Alright, so if we were to do the add multiply game here, this would end up being a -1 and a +3, because on the outside we would have a positive 6x, on the inside a -1x, which combines to that positive 5x that we need. So that's what we would do if it were a tricky trinomial. Well guys, this is really no different. Instead of just a plain x, we have a sine of x. So instead of starting off 2x, we're going to start off with 2 sine of x, and then a sine of x. That's kind of like the 2x and the x up above. Now the -1 and the +3 are still going to remain. So from there, it's equal to 0. We're looking to solve. So we have these factors. So what we now do is we set each factor equal to 0 and we solve. So if we go over to this side here, I can add over my 1, and then I could divide by 2, and hey, this 1/2, that is looking pretty friendly, pretty familiar. We know that the sine of 30 is 1/2, and since this 1/2 is positive, all right, in our ASTC, we know that in the first two quadrants is where sine is positive. So in the second quadrant, we would have to do 180 minus 30, and we'd get 150. So we have two answers from that. Now, and again, let's just keep it in degrees for now. Over on this side, we would have the sine of x is equal to -3, and this is not going to produce any solutions, okay? So if you think about y, your sine curve, okay, it goes up to a maximum value of 1, down to a minimum value of -1. Or if you think about your unit circle, okay, same idea. All right, it's going around, and the furthest it's getting is either 1 or -1, right? So it's never going to go beyond that. So it's not going to give us any solutions, okay? So our only answers are 30 and 150, okay? Which, when we write them in radians, 30 you should have memorized as pi over 6. 150, well, that's 5 30s, so that would be 5 pi over 6. All right, these are nice exact radian values. All right, last example, I promise. Sorry, this video is getting kind of long, but it's important that I show you one of each of these because you'll be confused most likely if I don't. All right, so we're looking to solve this equation here, and notice this time we have a double angle on the inside. So let's first clean this up a little bit. Let's add over 1, so now it's equal to 4, and let's divide that 8 in front. All right, if I divide that 8 over to that 4, I'm left with a 1/2, right? 4 divided by 8 would be a 1/2. Okay, so all I did was just divide by 8. All right, so our initial equation has now been simplified down to just this. Now, I want you to kind of box this in for a moment. If this were just a plain x, if the equation were sine of x equals 1/2, it'd be easy. As a matter of fact, it's the last example we just saw. We ended up with sine of x equals 1/2, and the answers were 30 and 150. Well, this inside angle is what is equal to 30 and 150. So we're going to write it like this. 2x is equal to 30, and it's also equal to 150. So pretend it's just a plain x, all right? Well, we know it's not just a plain x. It's equal to a 2x, okay? Let me back up for a second, though. If this were just a plain x, and we're talking about an interval up here that has some negatives in it, we said that we would have to also subtract 360 to each of these values, okay? So if I were to take this 30 and subtract 360 and this 150 and subtract 360, again to back it up a cycle, I would get negative 330 and I would get negative 210. So all of these are equal to what we call 2x. Okay, that's just what the angle is on the inside. Okay, well, we're looking to solve for x. We don't want 2x. So 2x is equal to all four of these things. So if this were your equation, all right, for all of these, you would know to hopefully just divide by 2. So that means x would be 15. That's within my interval. X would be 75. That's within my interval. X would be negative 165. That's within my interval. And x would be negative 105. Okay? So we're not going to reject these numbers here because they're outside of our interval. Okay? This is the interval for x. It's not the interval for 2x. Okay? So in the end, it's the x values that have to fall within that interval. So you're just treating this 2x as like it's just a regular x. You're going through this process that we did before. The only difference is you're dividing by 2. If this were a 4x, well, then you divide by 4. Okay? You get the idea, hopefully.